Good morning, students. This lesson is of class 8th for the subject of physics. Topic: concept of potential difference and electrical resistance, which is given in chapter 9, current electricity, of your textbook titled Concise Physics by Selena Publications, and is being submitted to you on 25th January 2021. Now coming to the first topic for today, that is potential difference, which is represented by letter capital V. The potential difference between the two conductors is equal to the work done in transferring a unit positive charge from one conductor to the other conductor. So what is the potential difference? Students, suppose you are having two conductors A and B. So A and B are two conductors, and I am taking a unit positive charge from conductor B to conductor A. Students, if there is a pencil kept in front of you, if you want that pencil to move, you have to pick that pencil and place it to the other point. You need to do work for displacing the object. Here also, when the charge is moved from one conductor to another, we are doing some work. So potential difference. So whenever we are talking about difference, difference is always final minus initial value. So we are going from B to A. That means final destination is A. We are reaching at A starting from B. So B is initial value. Suppose potential at B is VB and potential at A is VA. So what is potential difference? Final minus initial value. VA minus VB. Final potential minus initial potential. So potential difference is defined as work done in moving a charge. Charge is represented by letter small q. So work done in moving a charge from B to A. That is from one conductor to another conductor. So this is the definition of potential difference. Work done in moving a unit positive charge from one conductor to another conductor is known as potential difference. Students, potential difference and potential is a scalar quantity. It is not a vector quantity. It is a scalar quantity, and mathematically, potential difference can be written as work done per unit charge. So the SI unit of work done is joules, while charge is measured in coulomb. Now students, SI unit of work is joule. Work is measured in joule. Charge is measured in coulomb. And students, remember the SI unit of potential difference is volt. Potential difference is measured in volt. 1 volt. If we have to define volt, then what we will do? Put all the units in the formula. So I can say 1 volt. Instead of potential, I'll write down volt. Instead of work done, I will write it as joule, 1 joule. And charge means coulomb, 1 coulomb. So 1 volt is equal to 1 joule per unit, 1 coulomb. Now let us learn to define SI unit of potential difference. Students, the SI unit of potential difference is volt. But if question comes, define the unit. Define means we have to give definition of volt. So then you write down this formula. 1 volt is equal to 1 joule per unit, 1 coulomb. And then let us write down the definition. Potential difference between 2 points is said to be 1 volt if work done in transferring 1 coulomb of charge, work done in transferring 1 coulomb of charge from one point to other point is 1 joule. It is very simple to understand. How to define 1 volt? If work done in moving a charge of 1 coulomb from one point to another point is 1 joule, then we say that potential difference between the 2 points is 1 volt. So now coming to the new concept, a new term we will study today, and that is electrical resistance. Students, when current flows through a metallic wire, it offers some obstruction called resistance to the flow of current through it. So what is an resistance? The obstruction offered to the flow of current by a conductor is called its electrical resistance. So what is resistance? Repeat the definition with me. The obstruction offered to the flow of current by a conductor is called its electrical resistance. Students, you have to learn this definition as it is very important. Now, what is the cause of resistance? Why does resistance occur? Why does a conductor opposes the flow of current? Now, students, see the first diagram drawn on page number 2 of the notes sent to you on 25th January 2020. Students, here the first cylindrical tube represents the conductor, and in conductor we are having positive metallic ions as well as negative electrons. So positive metallic ions. Students, positive ions does not mean they are protons. No. So we are having positive ions and negative electrons. So students, as you can see in the diagram, the electrons are moving randomly. Positive ions do not move, but electrons move randomly. Some electrons are going towards left, some are going towards right, some of the electrons are going diagonally downward, some of the electrons are going diagonally upward. Similarly, many electrons must be going in upward direction and many might be going in downward direction. So we can say that if there is no cell, I have not connected any source of electricity. I have not connected any cell or battery in the first diagram. So if there is no cell connected with the conductor, then all the free electrons inside the metal conductor starts moving in random manner. Random means any direction, any arbitrary direction. There is no particular flow direction of electrons, but the electrons are moving in any random direction. But what happens if I join a cell across the ends of the conductor? Then you see figure number 2, the second diagram. Here, when the ends of the conductor are connected to a cell, as we have already learned that current will flow from positive end of the battery or a cell to negative end of the cell. So the current is flowing from positive terminal to negative terminal. Now students, as you have discussed in class 7th, that opposite charges attract each other while like charges repel each other. Now see students, the electrons are negatively charged particles. What are electrons? Negatively charged particles. Now, can these negative charged particles move towards negative terminal of the cell? Can negative electrons come towards negative terminal? Negative will repel each other. They will not attract each other. So what will happen? The electrons will not move towards the negative terminal of the cell because like charges repel each other. Rather, all the electrons will start moving towards the positive terminal of the cell. All the electrons will move towards positive terminal of the cell. So see, the direction of flow of electrons in figure number 2 is not random. Now all the electrons are moving in one direction. And what is that direction? Towards the positive terminal of the cell, since the positive terminal is attracting the negative charged particles. Students, kindly remember that the positive metal ions remain stationary. They don't move from the place. They are at rest. Only the electrons are moving inside the conductor. And if this conductor is connected with cell or a battery, then all the electrons are moving in one direction. But students, during their movement, they collide with the fixed positive ions and other free electrons of the wire, and due to which their speed decreases and sometimes their direction of motion also changes. Now what happens when the electron is moving, there is chances that it collides with the positive metal ion. During collision, there are two possibilities. Sometimes the speed of the electron decreases, or even its direction of motion changes. But ultimately, it has to reach till positive terminal of the cell. These electrons will again accelerate towards the positive terminal. So the electrons after collision, when their speed has decreased and direction of motion has changed, then also the electrons will again accelerate towards the positive terminal and will again suffer collisions with other positive ions, and this process will continue till the electron reaches towards the positive terminal of the conductor, which is connected to positive end of the cell or a battery. Now students, due to this reason, the electrons do not move in bulk with increasing speeds. Bulk means many electrons. It is not possible that large amount of electrons are reaching with high speed from one end to other end of the conductor. Why so? Because there were so many collisions in between the journey. Therefore, we say that the electrons drift towards the positive terminal. The word drift. The electrons do not move with higher speed. Rather, we use the word drift. The electrons drift towards the positive terminal. They will be moving slowly, approaching slowly towards the positive terminal. And this is the way how a conductor offers resistance to the flow of electrons. As studied above also, resistance is defined as the obstruction offered to the flow of electric current, and it is a scalar quantity. Resistance is a scalar quantity. Now let us learn the SI unit of resistance. Students, resistance is measured in ohms and it is denoted by a Greek symbol. And the cis symbol is represented for ohms. So the resistance is measured in ohms. SI unit of resistance is ohms. And if we want to draw a symbolic form of resistance in an electric circuit, we have to draw it as the spikes shown in the diagram. This is the symbolic representation of resistance in an electric circuit. With this, I come to an end of this interactive session. Students, you all are requested to do question number 3, 4, 5, 6, 7, 8 and 9 from your physics textbook in your physics notebook. Thank you students and have a nice day.